Hi, my name's Kelly Gourdji. I'm a postdoc at the University of Amsterdam. And in this lightning talk, I'll be presenting the LOFAR strategy to follow up on gravitational wave merger events. So the radio afterglows of gravitational wave merger events arise when the merger ejecta shocks the ambient medium to produce this synchrotron radio afterglow. So this afterglow contains a wealth of information about the merger ejecta, as well as some key merger properties, but they're really difficult to detect given the fact that they're relatively faint, but potentially more importantly, because the error boxes on gravitational wave merger events are notoriously large. So ideally, you want a radio telescope that provides a large field of view, but also has really decent sensitivity. And in this way, LOFAR is a powerful gravitational wave follow-up tool. So indeed, LOFAR has been active in the follow-up of GW events since the first GW observing run back in 2015. In 2017, during the second GW observing run, LOFAR followed up on a black hole neutron star merger candidate. As you can see, the error box is quite large, but we covered quite a large portion of this error box extending over 300 square degrees at a sensitivity of 8 millijanskis. This was quite nice, but unfortunately the event was retracted. However, we were still able to use this field to establish our radio transient search strategy. So in the latest gravitational wave observing run 03, the error boxes on the GW event locations had improved significantly. And with a single multi-beam LOFAR observation, we were able to obtain instantaneous coverage of about 20 square degrees. And given that this is a much more manageable size relative to 300 square degrees, we were able to calibrate these fields much more carefully. And in fact, we were able to obtain a nice uniform mosaic with a uniform sensitivity of 1 millijansky. And this bodes really well for the upcoming gravitational wave observing run 04, where the localization error boxes are supposed to improve significantly. And a single LOFAR multi-beam observation should be able to cover most, if not all, of the GW localization regions. In addition to late time gravitational wave follow-up that I described, we'll also be using LOFAR to perform triggered rapid response observations of gravitational wave merger events to search for any prompt related FRBs.